Greetings, welcome to the Get Solution India. I am Dr. Nandkishore Yadav. In this lecture, we will take some question on the Clipper circuit. So we will discuss about Clipper circuit. So we will discuss about the Clipper circuit. Okay. So we already discussed the theory about Clipper circuit. It clip the input waveform. Okay, and we get a output as a clip. Okay. So it may be clip the negative waveform, or it may be clip the negative part of the input waveform, or it may be clip the positive part of the waveform, or it may be clip the some part of the waveform. Okay, depend on this circuit. Okay, so in this question, the question is about for a circuit shown for this circuit below. Assume that the Zener diode is the ideal. Zener diode is ideal. It means threshold voltage of this Zener diode is equal to 0. Means it will on immediately. Okay, output characteristic of this Zener diode is like that. It is on immediately. Okay. After that, so this is the characteristic V in versus I. Okay, Zener diode forward characteristic. This is the forward characteristic. So there is no threshold voltage like this. VTH is equal to 0. So it will on immediately. After that, with a breakdown, Zener diode is ideal with a breakdown voltage 6 volt. Okay, so its reverse bias breakdown voltage is 6 volt because this is a Zener diode that has a Zener breakdown voltage 6 volt. So Zener breakdown voltage means when we apply a reverse biasing, it will break down after the 6 volt. This is a 6 volt Zener breakdown. Vz is equal to 6 volt. Okay, and it will allow the maximum current. The waveform observed across the Ops. Now we need to calculate this VO. Okay, means waveform observed at this resistance R. This R. So we need to calculate this VR. Okay, so what is the output waveform? So before proceed to calculate the output waveform, first we need to draw the input waveform. The given input voltage is 12 sine omega t. So first we need to draw this input waveform. If we are able to draw this input waveform, then further we can go for the output waveform. Because there is in this question the waveform is not given. This is given in form of this voltage. The given input voltage is 12 sine omega t. So sine omega t is the waveform. So sine is the input waveform. So we can easily draw the sine waveform. We know that the sine can be drawn like that. Okay, this is the positive half of this sine waveform and this is the negative half of this side with respect to the time t, and this is the amplitude, positive amplitude of this waveform. This is the negative amplitude of this waveform. And from this is known as the amplitude A, and this is the sine, and this omega is the frequency. Omega is equal to 2 pi f, and this t is the time. Okay. So the given amplitude is 12 volt. This is the 12 volt. So from this given input, I already drawn the input waveform. This is the input waveform for this input that is given in this question. So this is the input waveform, sine waveform, that has the amplitude of 12 volt and minus 12 volt. Okay, now after that we need to calculate, or we need to draw the output waveform. So how can we draw the output waveform? So to draw the output waveform, first we will draw the output waveform for the first half cycle. First part means for the positive half cycle. So we will draw the output waveform for the first positive half cycle. First positive half cycle means we are going to draw the waveform for positive half cycle. So whenever we will go for the analysis, first we need to analyze the diode for positive or negative half cycle. What is the condition of diode? Okay, in the positive half cycle, okay, this is P, this is N, so we are applying positive here and negative here. So this diode is in reverse bias. So diode is in reverse bias means there is no current flow between this to this node, means there is no current flow through this resistance. But after 6 volt, it will allow to draw a current or flow of current from this terminal to this terminal, because at the after the 6 volt there is a general breakdown will come, because after 6 volt general breakdown will come, V z is equal to 6 volt. Okay, so at the general breakdown it will allow a maximum current. If it allow maximum current, then there is a voltage drop across the R. Okay, so when it will allow the current after the 6 volt, so first we need to calculate what is the condition of this diode. So condition of diode is reverse bias. So diode is in reverse bias. Okay, and second is it will allow current after 6 volt. It means what is the value of input? Input is 12 volt, because 12 volt is greater than 6 volt. That's why it will allow the current. Okay, because after 6 volt it break down. Okay, that's why it allow the breakdown. So we can replace this general diode by its equivalent voltage by supply. Okay, is this 6 volt. So after that, after the all the analysis, we will draw the equivalent circuit of this. So from the analysis we conclude that it has a 12 volt maximum supply voltage, and here there is a equivalent 6 volt VZ supply. Okay, general breakdown supply, and here there is a resistance R. Okay, now we need to calculate this VR voltage at this node VR. Okay, so we can easily calculate this by the KVL. This is the positive, this is negative, this positive, this negative, this is positive, this is negative. So we need to calculate voltage across this VR. Okay, so just take a apply the KVL. I am taking the positive second sign here. So this is the second sign is positive, this second sign is negative, its second sign is negative. So plus 12 minus this VZ minus this VR. Okay, now is equal to 0. So after KVL I get this equation. So from this we know the value of VZ. This is equal to the 6 volt. Okay, so from this we can get the VR is equal to 12 minus 6 is equal to 6 volt. Okay, so in the positive half cycle we get VR the maximum 6 volt, and after this input value of 6 volt, so we can draw the output waveform for positive half cycle. We analyze that up to 6 volt, when we increase the input voltage 0, 1, 2, 3, okay, so up to 6 volt it will not allow the current. Okay, so V out is equal to 0, so up to 6 volt there is no current. After 6 volt it allow the current. Okay, and maximum voltage will go up to the 6 volt. So after 6 volt it allow current, and maximum output voltage is 6 volt. Okay, now we will analyze the negative half cycle. Negative half cycle means this is cycle. Now we will calculate the condition of the diode. Means we are applying negative half cycle. Means here is the negative, here the positive, means current will flow in this direction. In this direction we are applying positive here and we are applying negative here. It means this is the P and this is N. Means this diode is in forward bias, and this is the ideal diode. Means after the small change in the output in Bin, it allow maximum current. Okay, so there is a flow of current in this loop. Okay, so we can draw the equivalent circuit for this. The equivalent circuit for this is, so in this condition diode in forward bias. Okay, so equivalent circuit is there is no voltage drop across the diode. This is the supply voltage minus 12, and this is the resistance R. Now we need to calculate the VR across this voltage. Okay, so what is the value across this? Minus 12. So VR is equal to minus 12. So maximum voltage in the negative half cycle is equal to minus 12 volt. So when we increase the negative supply voltage, okay, so at this node, so after 6 volt, okay, so this is the Okay, so when we apply the negative half cycle, it will the output voltage also increases and goes to negative, and again it will repeat, and at the negative cycle it will go maximum up to this 12 volt. So this will go maximum up to the 12 volt. It will go up to minus 12 volt. So this is the output waveform for this circuit, plus 6 volt and minus 12 volt. So this B is the answer for this circuit. Thank you very much.